Hi, this is another video from Butte High Math. I hope you enjoy. Today's goal is to raise a power to another power. In words, the explanation says that to raise a power to a power, all you have to do is multiply the exponents. For example, the power m cubed could itself be squared, so you're squaring another power. Squaring means to multiply something by itself. So that means that you would be taking m cubed and multiplying it by itself, m cubed. Each one of these m cubed really stands for m used as a factor 3 times. The exponent tells you how many times to use the base as a factor. So this m cubed also means m used as a factor 3 times. Well, m cubed times m cubed gives us how many m's? That's right, it gives us 6. So the short way to cut through all of this would be to just take the initial 2 exponents, 3 times 2, and multiply them to get m to the 6th. This is a pretty easy example, and of course they get a little more complicated. Here's another pretty simple example. If you just remember that you can multiply your 2 exponents, q to the 10th raised to the 10th power becomes q to the power of 10 times 10. And I think most of you know what 10 times 10 is. That's right. This would be written as q to the 100th power. Good job. That's as simple as it gets. Z to the 8th raised to the 0th power times z to the 5th combines several properties of powers. I hope you remember that we love this kind of an expression because anything raised to the 0th power is 1. And of course, because of the identity property, anything multiplied by 1 equals itself, so we can just worry about the z to the 5th power portion of this expression. I love those kinds. They look hard, but they're really easy. Here we've got two different bases raised to powers that are also raised to a second power. So let's deal with this first part. If we just multiply the exponents on m, we have 3 times negative 1, which is, that's right, m to the negative 3rd. So you're going to have to be thinking to yourself what you do when you have a negative exponent. And then if we take the x portion of this expression, x squared raised to the 5th power, and remember you're multiplying your exponents, 2 times 5 puts an exponent of what on your x? That's right, and it's an exponent of 10. So now we've got this negative exponent business, and if you remember from previous lessons, raising anything to a negative exponent really means that it changes places in the fraction. So this would be considered on the numerator of a fraction over 1, and because this is a negative exponent, it's going to go into the bottom of a fraction, and the exponent is going to become positive. So our final answer is the expression x to the 10th power over m to the 3rd power. Good job. Now don't freak out, but I did want to show you something kind of cool. Look at this nonsense. 243 raised to the negative 1/4 power, which we hate because of the fraction and the negative and the huge number, but we can do this. And then that is raised to another negative fraction. But it's going to end up being not so bad. If we just remember that we can multiply our exponents because we're taking a power of another power, we can multiply negative 1/4 times negative 4/5. 2 negatives means a bad guy is leaving town. That is a good thing, so we're going to end up with a positive fraction. Cross-canceling means that we can cross out these 2 4s, so this terrible multiplication of fractions only ends up being 1/5. That's not so bad. A positive 1/5. if we look at it as 243 written to the 1/5 power, this looks bad unless you are familiar with the fact that to the power of 1/5 is exactly the same as the fifth root of something. So that's really like asking what number used as a factor 5 times would give you 243. So the number used as a factor 5 times to make 243 is 3. Isn't that a much easier way to write this ugly expression? I hope this has been helpful for you. We've learned today how to write a power of a power. Thanks so much for tuning in. This has been a production of Butte High Math.